This is 7.3, part 2, where we're focusing on a new property called the one-to-one property. Notice that you have two exponential sides. You have a base b with another side, base b. These are both raised to the same x and y. So then what we say then is these two would equal each other. Their exponents would equal each other. So I just have a couple quick examples here. We want to solve these two equations for x. So notice the one-to-one property. These two have the same base, so then these two will have the same power. So the value of x then is 3. We can also use the one-to-one property. If my exponents equal each other, then my bases would equal each other. So what does x equal in this equation? X equals 2. So that's how you can use the one-to-one property. Next example, this is a little bit more difficult. We want to find out what can x be. So in this question, 5 equals log base x of 32. And we want to find out what the base of this logarithm is. So the first thing we do is we can rewrite it to an exponential form. So we have x raised to the 5th power equals 32. Now we can rewrite this 32 to an exponential. 32 is the same thing as 2 to the 5th. Now that we can use our one-to-one property. We have two exponential values, one on the left and one on the right. My exponents equal each other, so then my bases must equal each other. So then my value for this equation is 2. So if you want to find out what x is, x equals 2 in this question. Our last topic today is to graph and this exponential function and its inverse. So when you graph this exponential equation in the red, we substitute values in for x. So let's just start with 0. 4 to the 0 power. We know that anything raised to the 0 power is 1. Now let's substitute 1 in. 4 raised to the 1 is 4. Substitute 2 in. 4 raised to the 2 is 4 times 4, which is 16. Now let's go to the negative 1 and then negative 2. 4 raised to the negative 1 is the same thing as 1 over 4 raised to the 1 power, which is 1/4. And then 4 raised to the negative 2 is the same thing as 1 over 4 squared, which is 1/16. Now let's go ahead and graph this. So first order pair is over 0, up 1. Next order pair is over 1, up 4. And then next order pair is over 2, up 16. Now we can go left 1, up 1/4, left 2, up 1/16. What's going to happen is our red exponential function is going to look like this. It has a base of 4, so we say y equals 4 to the x power. To find its inverse, if you remember from the earlier section, to graph its inverse, we just switch these values from this function. These are inverses of each other. So all of these ordered pairs are just going to flip-flop. So now this is going to become 1, 0. That's coming from 0, 1. Our next order pair is going to be 4, 1. That's the interchanging of 1, 4. Then the next one is 16, 2. That's the flip-flop of 2, 16. And then we have 1/4, negative 1, and 1/16, negative 2. Now let's graph this logarithm of base 4. So first order pair is over 1, up 0. Next order pair is over 4, up 1. Next order pair is over 16, up 2. And then if we graph 1/4, we're over just a very small amount, down 1. And then again, over a very small amount, down 2. So here's what the logarithm of base 4 would look like. So when I graph these, I always graph its inverse function first, whatever its base is. In this case, this is a base 4. So you graph its exponential of base 4, and then just flip-flop the ordered pairs. Our lesson is now complete. This is your assignment for section 7.3, page 509, 1 through 24. Have fun.